If you are a pen tester, you will come across one term repeatedly: reverse shell. In this video I explain what a reverse shell is, how it works, and what it is used for. This video is for educational purposes only. First of all, we clarify the question, what is meant by a shell? In simple terms, it is an interface through which a user interacts with the operating system. But why is it called shell? Well, the kernel is the operating system's core, and the shell forms the outer skin, so to speak. With the help of simple commands, you can navigate through directories, start programs, or manage permissions. In this video I used the term shell to refer to the bash, which is the Linux equivalent of the Windows command prompt. But what is a reverse shell? Well, if you want to connect to a server or your Raspberry Pi, the connection request usually comes from you. Therefore, you can use the SSH protocol. You enter a username, an @ and the IP address of the device you want to connect to. You will then be asked for a password, and if you enter it correctly, you can operate the device via a shell. With the reverse shell, you do exactly the opposite. Instead of you connecting to the target connects to you and offers you a shell. Unlike SSH, you don't have to log in, but the target provides you with everything you need. To be able to build a reverse shell, two things are necessary: a program which accepts incoming connections on your computer, and a command on the target computer which then voluntarily establishes a connection with you. A popular program that can be used to provide a listener for incoming connection requests is Netcat. When you call the program, you specify a port number to which the target computer will later dock. To do this, you have to get the host to voluntarily connect to you with a command. Let's have a practical look on how this works. But before we do that, let's briefly clarify the question of why reverse shells are used anyway. Well, the attacker does not have to log in to the target computer. SSH is often not even activated, which would make the connection more difficult. Moreover, unscheduled connections from the outside are usually recognized as a threat. Since the target connects to someone else on its own in the case of a reverse shell, the firewall may not respond unless, of course, you use strict positive listing or block certain IP addresses. Now I'll show you an example of how you can build a reverse shell in practice. For this purpose I have opened a vulnerable web application here on the CTF platform TryHackMe, which allows me to execute code on the target system. This is completely legal on TryHackMe because it's a well-known CTF platform. Behind a semicolon, I can now insert the code that can be used to build a reverse shell to my machine on the left. For almost all possible use cases, there's already code to be found on the internet with which the construction of a reverse shell is possible. I will use the appropriate code for a reverse shell from pentestmonkey.net and insert it after the semicolon in the vulnerable web application. Of course, in order to establish a connection later, we need to adjust the IP address and port here to our specific case. To do this, we look at the attack computer to see which IP address we have. The ifconfig command helps us to do this. This is the IP address of our local computer, which you can recognize by the ETH0 port. We now enter this IP address in our code for a reverse shell. Now we have to change the port. But to what? Well, so far we are not ready for incoming connection requests on our machine. We change that with the help of Netcat. For this we enter the command nc. With switches we can define a port on which we wait for incoming connection requests. I choose port 2222 here and enter it into our payload on the target computer. After clicking enter, you see that our machine is now waiting for someone to connect. On the target computer, I now click on convert and I'm connected to the web server on my side. This is my IP address and this is the IP address of the web server, which you can also see in the URL bar up here. We are logged in as the user challenge and can now look around on the server, start programs, etc. Thank you for watching and see you next time.